Assalamualaikum. Hi guys, ni hao, cha hao, annyeonghaseyo. Commit with me, Sindy Savella. Okay guys, this video was made to complete the final project for English course of physics. Well, I will explain material about factor. Do you know factor? No? No? It's okay guys. It doesn't matter if you don't know, I will tell you what is the factor, okay? Factor in physics, a quantity that has both magnitude and direction. It is typically represented by an arrow whose direction is the same as that of the quantity and looks like is proportional to the quantity's magnitude. Physics deals with a great many quantities that have both size and direction, and it needs a special mathematical language, the language of factor, to describe these quantities. This language is also used in engineering, the older sciences, and even in common speech. If you have ever given directions such as go 5 blocks down the street and then hang a left, you have used the language of factor. In fact, navigation of any sort is based on factors. But physics in engineering also need factor in special ways to explain phenomena involving rotation and magnetic forces. First, factor and scalars. A particle moving along a straight line can move in only two directions. We can take its motion to be positive in one of these directions and negative in the other. For a particle moving in 3 dimensions, however, a plus side or minus side is no longer enough to indicate a direction. Instead, we must use a factor. A factor has magnitude as well as direction, and factor follow can turn factor rules of combination. A factor quantity is a quantity that has both a magnitude and a direction, and thus can be represented with a factor. Some physical quantities that are factor quantities are displacement, velocity, and acceleration. Not all physical quantities involve a direction. Temperature, pressure, energy, mass, and time, for example, do not point in the spatial sense. We call such quantities scalars, and we deal with them by rules ordinary algebra. A single fluid with a size as a temperature of 40 degrees Fahrenheit specifies a scalar. The simple factor quantity is displacement or change of position. A factor that represents a displacement is called reasonably a displacement factor. Similarly, we have velocity factors and acceleration factor. If a particle changes its position by moving from A to B in fact A, we say that it undergoes its displacement from A to B, which we represent with an arrow pointing from A to B. The arrow specifies the factor graphically. To distinguish factor symbols from other kinds of arrow in this book, we use the outline form of a triangle as the arrowhead. In Fig A, arrow from A to B, from A to B, and from A to B have the same magnitude and direction. Thus, they specify identical displacement vectors and represent the same change of position for the particle. A vector can be shifted without changing its flow if its length and direction are not changed. The displacement vector thus is nothing about the actual path that the particle takes. The Fig B, for example, of three paths connecting points A and B correspond to the same displacement vector, that of the Fig A. Displacement vectors represent only the overall effect of the motion, not the motion itself. Second, adding vector geometrically. Suppose that, as in the vector diagram of Fig A, the particle moves from A to B and the latter from B to C. We can represent its overall displacement, no matter what its actual path, with two successive displacement vectors, AB and BC. The net displacement of these two displacements is a single displacement from A to C. We call AC the vector sum, or resultant, of vector AB and BC. The sum is not usual algebraic sum. In Fig B, we redraw the vector of Fig A and relabel them in the way that we shall use from now on, namely with an arrow over an italic symbol, as in vector A. If we want to indicate only the magnitude of the vector, a quantity that lacks a sign or direction, we shall use the italic symbol as in A, B, and S. You can use just a handwritten symbol. A symbol with an overhead arrow always implies both properties with a vector, magnitude and direction. We can represent the relation among the three vectors in Fig B with the vector equation, which says that the vector S is the vector sum of vector A and vector B. The symbol plus in EQ and the word sum and add have different meaning for vectors than they do in the usual algebra because they involve both magnitude and direction. Figure suggests a producer for adding two-dimensional vector and geometrically. Well, that's all. I can explain about vector, especially scalar vector and adding vectors geometrically, because if I explain all types of vectors, our duration is not enough. Okay, see you in the next video.